Hi everyone. Now we are going to discuss about the wireless communication of Unit 3. So Unit 3 named as digital signaling for fading channels. That digital signaling for fading channels contain so many subtopics. So structure of wireless communication link, principle of offset QPSK, P by 4D QPSK, minimum shift keying, Gaussian minimum shift keying, error performance fading channels, OFDM principle, cyclic prefix windowing, PAPR. Isn't it? So these are all the subtopics of Unit 3. So that Unit 3 contain objectives and outcomes, So whatever may be the unit, that unit contain objective and outcomes. So now we are going to discuss about Unit 3, So what is the Unit 3 objectives? To understand the concept behind the various digital signaling schemes for fading channels and analyze their performance. So what is the outcomes of the third unit in the sense? Learn the design of various signaling schemes for fading channels is the outcome of our third unit. Now we are going to discuss about our third unit subtopic. So block diagram of a digital receiver. So what is in the sense we are going to discuss about the block diagram of digital receiver. So first of all we are going to input as a input source, in wireless communication, whatever it may be the place, if we are going to give it as an input in the sense, so all the input are in the form of information source. So if you are going to give it as an information source into a RX filter, then the next that signal is entered into the low noise amplifier. Now we are going to discuss about that block by block uh, in next, So low noise amplifier, then the down converter, band pass filter, automatic gain controller, then A to D converter, then band pass demodulator, then here it is. So whatever may be the block diagram, that block diagram should working under the conditions of two categories. One is a modulation, another one is a demodulation. What is in the modulation? So modulation is a normal process. So demodulation is the reversible process. That means the modulation in the sense straightforward process. So demodulation in the sense the opposite process of modulation. Okay. Then demux, channel decoder, source decoder, D2A, because the modulation we are going to use as a to D converter, isn't it? So now we are going to use it as a D2A converter of demodulation process. These are the main difference. So at that place we are going to, at that place in the sense, so modulation side we are going to use it as a to D. Here we are use it as a D2A. These are all the very important things we are going to discuss about the modulation and demodulation process. So now the TX, that means a transmitter digital to analog converter, DAC, digital to analog converter. What is the use in this block? Generate a pair of analog discrete amplitude voltages. Then analog low pass filter. So transmitting the eliminate the spectral component outside the desired transmission bandwidth. So transmission local oscillator LO. So provides and the unmodulated sinusoidal signal corresponding to one of the admissible the center frequencies of the considered systems. Then the up converter. What is meant by up converter? All are in the transmitter side, because so the first part is the first part, isn't it? So that first part A to D, isn't it? So D to A. We are going to discuss about the A to D is a the convert analog filter band pass signal is mixing it with the LO signals. So second one, the RX transmitter filter eliminate out of the bands emissions in the RF domain. So third, next one is the propagation channel. What is the propagation channel? So the propagation channel is used to the attenuates the signal and leads to delay the unfrequency of dispersion. Finally, the environment add the noise, additive white Gaussian noise, AWGN is it, and a co-channel interference. In this way, the RX filter. Now we are going to discuss about the receiver filter, isn't it? So what is in the transmitter? What is in the receiver? A to D is a transmitter, D to A as a transmitter. So then only we are going to split it as the two, A to D, D to A. A to D once again, A to D as a transmitter, D to A as a receiver. So RX filter the bandwidth of the filter corresponds to the total bandwidth assigned to a specific services. So low noise amplifier, the amplifies the signal so that the noise added by the latter components of the RX chain has a less effect on the signal to noise ratio. So SNR in the sense the full form, the signal to noise ratio. Then RX down converter. The down converter, where it is the place we are going to use the convert the received signal into a baseband signals. That is the purpose of the down converters. Okay. So up converter, where it is the place we are used in a transmitter side. So down converter, where it is the place we are going to use, so receiver side. Then low pass filter. What is the low pass filter? If we are going to apply the whatever may be the signal, that signal we are going to get as output of low pass energies. So provide a selection of desired frequency band for a specific uses. It eliminates the adjacent channel interference as well as the noise. Then automatic gain control, AGC, isn't it? So AGC in the sense amplifies the signal such that it's a travel well adjusted to the quantization of the subsequent ADCs, because analog to digital, isn't it? So then ADC, what is the ADC? Analog to digital converter, isn't it? So convert the analog signal into values at discrete time signal, isn't it? Then baseband demodulator. What is the demodulator? Obtain so soft decision data from the digitized baseband data. Then the simple timing recovery uses the demodulated data to determine and the estimate of the duration of symbol and uses the finer tune the sampling travels. The decoder. What is the purpose of decoder? Here we are going to use it as uses the soft estimate from the demodulator to find the original, that means a digital data. It's like a original data, the source data. For a convolutional codes, the maximum likelihood sequence estimate we are going to use it because of the decoder purpose. Okay.